Hi, welcome back. We're going to continue talking about logs. We're going to write an inverse function of a log. That's like exponentiation. Then we're going to graph a log from the exponential function. Then we're going to talk about transformations, domain, range, and behavior, and an element called the vertical asymptote. The vertical asymptote. To find an inverse of a log, if it's presented to you as f of x is equal to log base 5 of x, go ahead and write it as y equals, just like we did before. Now we're going to switch the x and the y, literally switch them. So this becomes x equals log base of 5 of the input y. So remember with an inverse, and we talked about this the last couple of days, the x's and the y's are flipped. The domain and the range are flipped. One has a horizontal asymptote, which means the log is going to have a vertical asymptote. So let's write it as an exponential. So I have base 5 raised to the power of x, that's my exponent, has to equal my input of y. So there's my inverse. So this is f inverse. So now all we do is just write it in more of a standard form. F inverse of x equals 5 to the x. So go ahead and work through the video question. All right, welcome back. We're going to move on to find the inverse of y equals log base 12 of the input x minus 2. Notice that x minus 2 is in parentheses, so the whole input is x minus 2. Again, we're going to write it as y equals, and it's already in that form. So we're going to switch our x and y's. X equals log base 12 of the input y minus 2. We're switching our x's and our y's. Y minus 2. It's starting early on this one. Now we're going to change it and we're going to exponentiate to write it as an exponential equation. So my base is 12. My exponent is x. And my input is y minus 2. Notice that I dropped my parentheses because they don't, when at this form, they really don't mean anything. Now I'm going to add 2 to both sides so that I can isolate my y. So I get 12 raised to the x power plus 2 is equal to y. This is f inverse. 12 to the x plus 2 equals f inverse of x. And now I'm just going to write it in a more standard form with my f inverse on the left, and I get 12 to the x plus 2. All right, so why don't you try the video question, and then you can come back and we'll move on to graphing. All right, welcome back. Now we're going to graph a log function, and it can kind of hurt our brain a little bit. So let's just find the inverse, and let's find the points for the exponential, and then just flip them. How's that sound? All right. So my inverse, I'm going to flip my x and my y, and so you get x equals log base 4 of the number of the input y. Now I'm going to write it in exponential form. 4 to the x is equal to y. All right. So now I'm going to graph f inverse of x equals 4 to the x. So I'm going to plug 0 in, and I'm going to get a 1. I'm going to plug in -1, and that's going to give me 1/4. And I'm going to plug in 1, and that's going to give me 4. Okay, now you can plot those points And I'm going to actually do it for for this illustration, but on your work tomorrow you don't have to plot those points, okay? So at -1 I'm at a fourth, at 0 I'm at 1, and at 1 I'm at 4. So here is my inverse exponential function, okay? Now in order to do the log function, I'm going to flip my x's and my y's. So at 1/4, my y value is going to be -1. At 1, my y value is going to be 0. And at 4, my y value is going to be 1. So I'm going to graph this one. And so we're going to be here, and here, and here. And this is my log function right here. This is log . This is log base 4 of x. You won't be able to read that in there. I'm not going to try. I'm just going to do it in red. This is log base 4 of x in red. All right? Okay, so now let's talk about the domain. Look at what's happening here at this vertical line, y = 0. All right? So my, or x = 0. My graph is approaching that, so it's going to go, my smallest x value is going to be 0, and my largest is going to go to positive infinity. For the range, this keeps pointing down forever, so that's negative infinity to this keeps pointing up forever, positive infinity. Even though it's going up slowly, it's still going up. And my end behavior, as x goes to 0, f of x goes to negative infinity. And then as x goes to positive infinity, my f of x goes to positive infinity. Okay? And so basically it's the same thing. You're going to find the inverse function, graph it, that's my purple one, flip the x's and y's, that's going to give you your log graph, and then you're going to state the domain, the range, and the end behavior. Transformations work exactly the same way as they do in all other types of functions. If you have a negative out in front, you have a reflection. All right, so if it's a negative in front, then it's a reflection. If you have a number out in front other than 1, and a is bigger than 1, it's a stretch. If it's less than 1, then it's a compression. X minus h gives us our horizontal shift, and it's going to move h units. If it's minus, it's going to move right. If it's plus, it's going to move left. And k is going to move up and down. All right? So when we talk about our domain, it's always going to go from our h value to infinity. And when we talk about our range now, it's going to go from negative infinity to positive infinity. And behaviors are going to go from as x goes to that vertical asymptote, or h, and then f of x goes to negative infinity. As x goes to positive infinity, f of x is going to go to positive infinity for the most standard. All right, vertical asymptote. So instead of it approaching a horizontal line, our graph is now going to approach a vertical line, and that's going to be a vertical asymptote. It's going to be whatever h is. If h is 0, then the vertical asymptote is 0. If h is -4, then it's going to be a vertical asymptote of -4. So let's describe the transformations. I have a negative out in front, so I have a reflection. I don't have a number out in front, so I don't have a dilation. H is 0 and K is 0, so that's the only one that I have. Okay. Number 2, y is equal to 1/3 log base 4 of the input x. So I don't have a negative sign, but I do have an A. So this means that I have a dilation. And it's less than 1, so this means it's a compression. Number 3, I have y equals log base 4 of the input x plus 3. So I don't have a reflection because there's no negative. I don't have a dilation. My H value is 0. This is not in parentheses, so this is your K. So I am going to be up 3 units. Look at this one. This is an H. H is always going to be in the parentheses. K will not be. That's how you tell the difference. So this is x minus 2. So that means I'm going to go right 2 units, because it's the opposite sign inside here. I'm going to let you list all of the transformations for number 5. Y equals -2 log base 3 x plus 1 minus 3. And there's a bunch of them. That's your video question. So come back when you're done. All right, welcome back. Here we go. I have a reflection. That's the negative. I have a stretch. That's my 2. I have left 1, that's my H, and I have down 3, that's my K. This is my A, this is my H, this is my K. All right, so we're going to work on this assignment tomorrow. Thanks for listening, and I will see you tomorrow.